about geometry, and I'm going to use Geometer Sketchpad just for the moment. On this sketch, I'm going to put in a radius, and I'm going to measure that radius. All right, so the length of that is 4.75. I am also going to, what am I going to do? I am also going to, I think, I don't know if I need all of those points. Maybe I don't. Hold on. Let's see if it will measure an arc. Was it always going to measure the major arc? Hold on. It's been a while. It's been a few years since I've done geometry. So if I select the circle and I select the 2 points, I'm going to construct the arc.
It's like riding a bike.
Okay. And so can you see that this arc right here is highlighted? And I'll actually I'll make that a little thicker if that helps. Whoops. Okay, and I'll make the radius thick as well. I could. Would that help you?
Yeah.
Are you just saying that?
No.
Oh. All right. What color do you want them?
Purple. Magenta. Oh my god.
Like this guy? Is that good?
No, it's too bright. Stop us, Travis. This is my eyes. Can you make the arc gray? Gray like my
Okay.
soul.
All right. So I'm actually going to measure this arc, and I'm going to make an angle. And holy cow!
Whoa. Oh.
I'm going to measure this angle. All right, and so here's that angle, and I want a very specific angle, and I want that angle to be when, oh, it's not going to, all right, that's fine. I'll make it a little bit bigger. I am. Oh my goodness.
Oh god.
All right. It won't let me do that. I know. This is painful. I'm going to try my best. I can't. Okay. Thanks. No, we're good. All right. So there's a very, very special measure of this arc and this angle. Right? When this arc is exactly the length of a radius, we call this angle a radian. Okay? So if you can imagine taking this radius and sort of bending it along this arc so that these two lengths were the same, the angle there is called a radian. Right? In other words, this is the angle that makes a radius on the circle.
Wait, so the angle is called a radian?
The angle is called a radian. Okay? So a radian is around 57.28 degrees. That's crazy.
Is it always like that?
Yep. A radian is always 57.28 degrees because it doesn't matter how big or small the circle is, it's always going to be in the same ratio, and that angle is always going to be the same. If you think about it, actually, I have a better idea. Well, I don't know if it's a better idea. You'll tell me if it is in a second. Let's see. All right. Okay. So I know that right here is 1 radius. That's what this is. That's 1 radius. And I also know that we call this angle 1 radian. I want you to help me think about a few things. How many radiuses, how many radii go around the circle? All right, how do you get all this? What's the circumference of a circle equal to? 2 pi r, or pi times the diameter. In other words, the circumference is equal to 2 pi radii. And if this is 1 radii, that means in the whole circle there are 2 pi of those. So, 1 radian is the angle that does 1 radius. There are 2 pi radians that go in the whole circle. So, I have a little story that involves Anne, and it'll hopefully help you remember. Maybe it won't. You can tell me. All right. So, Anne is we'll let Anne be this black dot for now. All right. Anne is on the riverbank. She starts at the riverbank. Okay. And there are adoring fans on either side of the riverbank as she goes around this water wheel. Because they're interested in watching this frog go around the water wheel. When she gets to this riverbank, her fans cheer and give her presents and prizes. They give her 1 pi. Okay? When she gets around here, her fans give her another pi, so that when she's gone all the way around, how many pies does she have? 2 pi. So, going all the way around the circle is the same as 2 pi. Going halfway around the circle is pi radians. Okay? So you could say 180 degrees, or you can say pi radians. They say the same thing. Now here's the thing. You may very, 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 very well want to say 180 degrees because you feel more comfortable with it, but you need to get practice talking about in radians as well. Not because you're going to talk in radians, but because some other people might talk about in radians, like me. Like I might say, hey, this is 5 radians. How many degrees is that? Or this is 200 degrees. How many radians is that? So you can imagine Anne, when she's right around here, how far is she away from getting that pi? What fraction is she?
0.5.
Half. 0.5. She's halfway to pi. There's half pi. She gets her pi. Here's 3/2 pi.
Has she eaten the pie? Wouldn't down there be...
And here's 2 pi.
Wouldn't down there actually be like a pi and a half?
That's 3 pi. Is that what I said?
3/2.
Yeah, okay, fine. I thought I said the wrong thing. I said, I'm good. All right. Not only that, there are other important things that we might talk about. Pi, 30 degrees is around pi sixths.
So pi over 6.
Pi over 6. Okay? 60 degrees is pi thirds, or pi over 3. Okay? And we should probably come up with a conversion right now. But maybe this will help you remember. I don't know. You'll let me know in a couple days. So here's the thing. Hold on, Elizabeth. I'm almost there. 360 degrees is equal to 2 pi radians. Or 180 degrees is equal to pi radians. And those two ratios, or those two equivalents, will help you remember the ratio to convert degrees from radians. Everything all right? So, let's do an example. Let's do 45 degrees. So, if you want to know how many radians that is, there are a couple ways of doing it, but you can say 45 degrees is to x as 180 degrees is to pi. Do you see how they're in a ratio? 45 pi equals 180x, or x equals 45 pi over 180. Well, is that 0.25? Or 1/4 pi. So 45 degrees is equal to 1/4 pi, or sometimes we just say pi over 4. Let me do one more and then we can stop and do some questions. I could say, okay, the angle is 2/3 pi, and let's see. Here's the thing about mathematicians. If they tell you the angle is 2/3 pi and there's no unit, it's implied that we're talking about radians. So you could have 2 degrees, or if you just have 2, it's implied that it's 2 radians. 2 degrees and 2 radians are very, very different. 2 degrees is a very small angle. 2 radians takes you somewhere into the second quadrant. So it's very important to look. Sometimes mathematicians will do this. They'll put a little r for radians, but that's not very often. So if I tell you the angle is 2/3 pi and I want to know how many degrees it is, you could say 2/3 pi is to x as pi is to 180. Do you see what I did? Here I had degrees over radians in the first problem. In the second problem, I have radians over degrees. It doesn't matter. You could switch it up, but you just have to be consistent. So if I'm doing radians is to degrees equals radians is to degrees, I now need to do a little solving. 180 times 2/3 pi equals x times pi. 2/3 times 180? 120 pi equals x times pi. The great thing about the pi's, so x equals 120 degrees. So 2/3 pi is 120 degrees. Now look, I'm going to be honest with you. There's going to come a point in time where you're either going to memorize or you're going to just know so well. 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees. 120 degrees, 135 degrees, 150 degrees, 180 degrees. 210 degrees, 235 degrees, 240 degrees, 270 degrees. 300 degrees, 315 degrees, 330 degrees, 360 degrees. You're going to know all of those degrees and what their radian measurement is. And not only that, you're going to almost have memorized, if not memorized, be able to figure out very quickly what the sine and cosine of all of those angles are. I know. But when you think about it, if you know what the sine of 30 degrees is, if you know how high Ann is above, if you actually know that the sine of 30 degrees is 1/2, is that what it is? I think it is. It is, right? If you know what the sine of 30 degrees is, I say that you automatically know what the sine of 150, the sine of 210, and the sine of 330 are. Don't you? 150 degrees is just in the second quadrant. So the sine of 150 degrees is just going to be 1/2. The sine of 210 degrees, that's just the same thing in the third quadrant. That's almost the same thing, right? negative 1/2. And the sine of 330 degrees, is the same thing, except in the fourth quadrant, that's almost the same thing too.
So if it's sine, the first and second quadrants are positive, and
Uh-huh.
the sine, the first and fourth are positive.
Yep. You want to know, you're a man ahead of your time, Danny, but here we go. All students take chemistry. All right? Or calculus. I've heard crack. I've heard a whole host of things, but as juniors and seniors, haven't you all taken chemistry? So it actually makes sense. It's true. The other statements may or may not be true. All students take chemistry. And what this tells us is, in the first quadrant, all the trig ratio, all the trig ratios are positive. Sine and cosine, and we haven't talked about it yet, but tangent as well. In the second quadrant, sine is positive. Okay? The other ones are not. In the third quadrant, tangent is positive. Sine and cosine are not. And in the fourth quadrant, cosine is positive.
All what are positive?
The trig ratios. So in the third quadrant, cosine would be, so in this quadrant, cosine is going to be positive. The sine is going to be negative, and the tangent function, which we haven't talked about, is going to be negative. And those are the three big trig ratios. You can also think about it, though, is N above water or below water? Is N to the left or to the right? In the fourth quadrant, the plus means that N is to the right of the y-axis, but the negative for sine means that she's below water. Okay?
What does T mean?
Tangent, and we haven't done that yet.
Tangent's
Positive in the third quadrant. Sine and cosine are negative. Evan.
How cosine and sine kind of work together, I guess, and they're alike and they're similar.
Okay.
Is tangent completely different?
It's a little different. It's the ratio of the sine to cosine. So it's not, it's in some respects it is very different. That's true.
All students tickle cats.
All students tickle cats. All right. Let me see. All right. So look, we learned what a radian is. It's about 57 degrees. More importantly, there's a special relationship that exists. And you can either remember 360 degrees equals 2 pi radians or 180 degrees equals pi radians. Tonight, your homework is mostly focused on switching back and forth between radians and degrees. Because you are not accustomed to working in radians, you are going to want to keep working in degrees. And the goal of tonight is to get you to feel a little more comfortable knowing how many degrees every radian is. So if I say, hey, guess what? 3 pi over 4 radians, you'll be like, oh, that's 135 degrees. Yeah, it is crazy. It could be. I'm not against it. I'd be rooting for it. I don't know. Hold on, I was going to say one more thing. We're going to get more practice tomorrow. So, I know that the first time through, you're just going to be plugging things in and you might not be totally comfortable with it. The idea is to have a couple days so that by the time we're done, you can feel very good about radians and degrees and going back and forth. Okay? No one asked. Isn't it crazy? Why would we use radians? Why would we pick 57 point some odd degrees? Some things in calculus are a lot easier with radians. Okay? Evan.
If we just noticed built into the air, don't you think they would